No, technically we're just doing some examples in our notes. We're taking it for the juniors. We're going to grade our evens for 2-7 in just a second. We're just trying to solidify 2-7. I said, do you have to write this whole paragraph in your homework? And you guys said no. So what can we write instead of this whole big paragraph that still shows me that you're writing down the given information? Okay, we could start writing stuff like that, but question, didn't I say for these ones there's a system? No? Isn't there a system? Yesterday, all 4 of the related rates problems. Weren't we putting them into the same system? Okay. You don't have to do it this way in your homework, but I would at least think through each of these because then you won't miss any information. So, for instance, we have a point moving along a curve. Oh, well, that's kind of gross for the picture. I guess we could actually get a picture of this one in our graphing calculator, which would be kind of yuckies. So maybe this one isn't super necessary. Maybe we don't need the picture on this one. Okay? But, given. What are we given? We're given y equals x cubed plus 17. But isn't that better, maybe, fitting in this box? Because what's this box for?
Related.
What's this box for?
Related stuff.
The related quantities. Oh, that's how x and y relate. Okay, so that equation should go there. So what else is given besides the equation that's better in here?
An x and a y value.
An x and a y, but doesn't that sound a whole lot more like a such that or a when?
Yeah.
So I have when 2, 5. Okay, steak. Well, hold on. What else is in here? Y is increasing. Isn't that dy dt?
Yeah.
Can someone explain that to me? How do I know when it says y is increasing at who's this? The derivative of who? Of y.
Well,
So I can say 2 units per second. There's a bug. What are they asking for? Rate of who? X. Well, how do I show rate of x? dx dt, right? This one, there's not like a super complicated scenario or a picture or formulas that we have to pull out of thin air from geometry. It's not really thin air, but they gave us everything. We just have to use it. So kiddos, if I know the dy dt, if I'm trying to find the dx dt, and if I have my related quantities, or I have the relationship of the quantities, I don't even need a picture. Let's just go to this box, and this box says to do what? Derive. Exactly. We need the related rates. And to relate the rates, we have to take ddt at both sides, right? So we're going to take ddt of the left. We're going to take ddt of the right. This is where everything comes together. Because to derive the right-hand side, wouldn't you guys rewrite him? How would you rewrite him to make his derivative easier? Yeah, to the 1/2, right? X cubed plus 17 to the 1/2. Good? And then derive, and what do we get? dy dt is equal to 1/2. Keep the derivative of the inside, derivative of the outside, keep the inside the same. The negative 1/2 power. Did you guys do times derivative of the inside? 3x squared? You see my chain rule? Derivative of the outside, bring down the 1/2, put a negative 1/2, keep the inside the same, times the derivative of the inside. But what did I forget that I can't forget when I'm taking the derivative with respect to t? Yeah, x doesn't match the t either, so he needs a u prime as well. That's where the dx dt comes from. Now, this is kind of messy. It's kind of rough, but beware, you have non-calculus out. I'm technically supposed to be taking away whatever you have and keeping it till the end of the day. So make sure you put it away. 2 times the square root of x cubed plus 17 dx dt. Now what? What's in this last box, guys? What are we supposed to be doing? Plug and chug, right? Plug and chug what? I'm scared. I'm terrified right now.
But
Supposed to
Yeah,
plug
plug
in
in 2.
the dy dt.
Yeah, plug in the 2, the dy dt. Plug in the
2 for x value.
2 for x, and do
No,
we
we
plug
don't
in
know.
y anywhere?
No, there's none of them.
So I have 3 times 2 squared, which is 3 times 4, all over 2 times the square root of 2 cubed is 8. 8 plus 17 is 25. Dx dt. Dx dt is equal to
12.
12 over 10, right? 2 times 5.
Mhm.
12 over 10 is the same thing as 6 over 5. Multiply up the 5, that'd be 10. Divide the 6, 10 over 6, 5 over 3. I did a lot of mental math.
Yeah, it's probably.
Nice. And technically our units would just be unit per second, because if y is measured in units up here, then x will be measured in units as well. If t is measured in seconds up here, t will be measured in seconds down there. Now pause, this is an easier example. Coming back. This one, you didn't have to stress about geometry plugging. You didn't have to stress about going and finding clues and plugging in weird other rates and craziness. You just went for it. Are there any questions on the process? The big idea, what we're supposed to be doing. What's your given? What's your find? What's the relationship? Take the derivative, plug and check, done. Right? Are you sure? The process is okay.
Yeah.
So when we go and look at a multiple choice question like number 44, I'm going to go ahead and dual page it so that we can work on it together. You're not having to work on these alone, not right now. What makes number 44 harder?
Okay.
Do you see a formula? That's what makes it harder. You don't see a formula. They don't just give it to you like the last problem. Some related rates just give it to you. This one doesn't. So number 44. Just as I'm trying to show you guys, there's just a system. What am I doing? We're just going through, right? Okay, so go ahead and take a second, read. I want you guys to take a second, read, and try to fill in the given, the find, draw a picture. That's all I'm asking, just the first 2 boxes. Given, find, draw a picture. And if I were you, draw a picture first. Yeah, 5/8 centimeters. I say draw a picture first. If you guys are struggling a bit with drawing a picture. Equilateral triangle, all the sides are congruent, so that's my picture. That's easy. Just a little bit longer. You're just trying to say, can I take the paragraph and can I write it mathematically as to what's my given, what's my find? Well, they did give you a formula. Look, it's like the AP guys. They don't trust you to know the geometry formulas. That's okay. We'll take them, right? One less thing to memorize. Okay, so you guys are trying to fill in. Let me just read the paragraph. Let's see if you're able to pick out anything. The sides of an equilateral triangle are increasing at a rate, that's important, of 5/8 centimeters per second. At what rate is the area of the triangle increasing when the sides are 4 centimeters? By the way, the formula for the area of an equilateral triangle is A equals square root of 3s squared all over 4. Someone amazing, raise a hand. What did you write for given? Right.
ds dt is equal to 5/8 centimeters per second.
Do you guys agree?
Yes.
The rate of change of the side is 5/8 centimeters Second. Someone new, someone different. What did you write for the find? Brandon.
You want to find DABT?
How'd you put an A? How'd you know to put an A?
Because this is what rate is the area.
Good.
When S equals 4, so I put
Good. Someone new, someone different, someone amazing. What'd you put for the formula in the next box? Andrew.
A equals 3x squared over 4.
Bending the root soon, it's just root 3. Where'd that come from? Oh, they gave it to me. They gave me the relationship, right? Someone new, someone different. What's our next step?
DDX of A is equal
What, Christian?
DDX of A is equal to DDX of root 3 squared over 4.
Yeah, but don't do DDX. I know you want to because of how this chapter started, but technically, look and see, this is T, right? Because of time. So we're going to take DD, but DDT. Does that make sense?
Yeah.
Okay. So we're going to go ahead and take DDT of one side. We're going to take DDT of the other side. So the derivative of A is 1, but 1 times who? DADT. Oh, this other one looks horrendous. Can we rewrite them to make him prettier?
I like him the way.
You like him the way he is? You like the quotient rule?
Oh, no.
A lot of people would think to do quotient rule if we leave them like that.
Oh, okay.
So how can we rewrite them so we don't have to do quotient rule?
Square root 3 over 4.
Square root 3 is a number, 4 is a number, and then we have s squared. Doesn't that look easier? Square root 3 is a number, 4 is a number. It's a coefficient. Just pull that away from the s squared and then take ddt. Do I need quotient rule? No, all I need is power rule, right? Pop down the 2. 2 over 4 becomes 1 over 2. Square root of 3 over 2. I have an s, and since this s doesn't match the t, what else do I need? ds dt. Sweet. What's the last thing you finished? You guys should have it. Plug and chug, yeah? Alright, so you guys finish off the problem real quick and find me. Is it A or B or C or D? A or B or C or D? A or B or C or D? How's 5 root 3 over 4 looking?
That's looking good.
Good. My 2 people. We can plug and chug, right guys? We're in calculus, we're okay?
Good.
Alright.
Okay.
Just check in. 5 root 3 over 4, and if we had to look at our units, all those units are the same. But if we look at it, remember, area is measured in squared stuff, right? So centimeters squared. And time in this problem is measured, if we look back, in seconds. Dun, 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 dun. The answer is B. Now some of you are like, oh, okay, this is all well and good, but I thought today was a work day. I thought we were going to get homework done. Guess what number 44 is? Homework question. Hey, guess what else is a homework question?
Not 45.
Let's do him too. Sound good? Does anybody want a picture of 44 before it's gone? Go ahead. It's going to be saved online. It's in the video as well. But if you want a picture, go ahead and grab it. We got it?
Yeah.
Okay, 45. What am I going to do? Plug into the system. Oh. And the last problem, where do you think you should start?
I'm gonna draw a picture.
I would draw a picture too. Ready, set, go. A right
Oh, cylinder.
cylindrical water tank. Wait, what's a cylinder?
Like a can.
Like a soda can. Yeah, but like straight. Yeah. So start showing it. That's a cylinder, but make it straight. Yeah.
That's
Okay.
Oh,
That's
yeah,
okay.
you
Get a
did,
picture.
yeah.
Higher square each. You guys drawing the picture? A right cylindrical water tank with a diameter of 3 feet and a height of 6 feet is being drained. Picture. Draw a can.
Oh, that's beautiful.
Isn't it? Hey, some of yours look about the same.
Yeah, those,
It's not that bad. I just need to orient my board. Sorry, it's a struggle. Okay. It's even worse.
Where's Carl?
I know, him and his like 16 points of accuracy. Okay, anyway. Diameter of 3 feet and a height of 6 feet, is that right? It's being drained. Wait a minute, what's in him? He's full of water, yeah? And he's being drained, so somehow it's leaking out. I don't really know. Maybe there's like a hose and it's sucking it out. Anyway. If I was to label stuff, I have 6 and 3, but that's for the container. If I was to label stuff for the actual water level, I could have an R for him, right? And couldn't I also have an H for him? I know 6 and 3 is for the container, but R and H is going to be for the actual water himself. So I'm going to put a couple variables in there. Now, given and find. Okay, yeah, it's a lot nicer when it's oriented. Okay, given. What'd you guys pull out? At what rate? Wait, what? Yeah, go ahead.
The H, is that the 6 feet?
Well, 6 feet, that's the container, but the water's not all the way up if it's draining out, so H is however high the water is. Does that make sense? Okay. They actually don't start with a given, do they? At what rate? They're asking us to find. Okay, fine. Let's go with it. At what rate is the... Okay, so what do I put in my find? dV dt. At what rate is the volume of the water changing when, such that, when the water level of the tank is dropping at a rate of 4 inches per minute. Wait, the water level, that's the height, right? The water level, how high it is. When the height is dropping, okay, so my such that is a dH dt? Yeah.
Okay.
But, doesn't that make sense? When the height is dropping at a rate, well fine, my such that or my when was a rate equals 4 inches per minute. So what's my given? I don't know. I'll just say info. It wasn't anything separate. I put the 3 and the 6 in my picture, and then the when was dH dt equals 4. Alright, whatever. Brandon, you said a second ago, stink, I don't know the volume of a cylinder. Yes, I do. Why were you asking yourself that question? Why do you need that formula?
You need to know the volume.
I need the volume. So V equals, to help us all out, pi r squared h.
Hey,
Remember the AP assumes we don't know geometry, so there we go.
you don't.
Are we going to be given a formula sheet for the exam, or after we need something?
It's not a formula sheet, they'll put a little parenthesis at the end and be like, by the way, this is this.
Okay.
It's like equilateral, by the way, there it is.
Okay, cool.
But they won't do that for area of a square, area of a rectangle, or
Yeah.
area of a trapezoid or a circle. But everything else. Trapezoid, it'll actually be a forever circle in the future. Kiddos, do you see when we take a derivative, we'll have a dV dt? Now, wait,
Yeah.
listen. Didn't I say a little while ago, the sand cone problem is hard,
Yes.
and the trough problem in homework is hard, and the shadow problem in homework is hard. And I said all three have a common difficulty. This problem has it too. This problem has it too. So hang in there. We'll talk about the common difficulty. I don't know where.
Oh, because there's a problem there.
Oh, God.
I was like,
This problem has the same difficulty as the hardest ones in homework. Ready? I see a V, a d, v, dt. Awesome, I'm going to get him. I see an H, a dH, dt. I'm going to get him. But who else do I have in my formula I'm going to get that I have no clues about?
H.
Oh no, H is fine, right? I have a dH, dt.
Oh, sorry, R. But we know it's a constant. It's a constant. R is a constant.
Why is R a constant?
Because the side's not changing.
Imagine the picture. As the water drops, what happens to R?
It's the same.
The area stays the same. Now, the dilemma in all those homework problems, they weren't all constant. Some of them might have been changing. One of them, the trough problem, something remains constant. But the problem is you have this extra variable and you need to figure out what to do with him. But in this one we say, hey, R is unchanging, so actually before we even take a derivative, what can I plug in from this picture? Who is R the entire time? 1.5 or 1.5 or 3/2, right? So I can actually take my volume formula, I can plug in 3/2 squared, which would be 9/4, and now I have 9/4 pi h.
It's easier than doing products.
Why is it better?
They don't have to do product rule.
You don't have to do product rule number 1, and number 2, I'm not going to have this funny dr dt somewhere messing me up. So now I can say, sweet, let's just take the derivative. So make sure you keep an eye open on your problems and see if there's something that's not changing or unchanging. So now we have dv dt is equal to 9/4 pi is a constant, right?
Mm-hmm.
So 9/4 pi is just chilling times, what's the derivative of h? 1 dh dt. Can you guys plug and chug into him?
Yeah.
Yeah. At the end of the day, when you plug and chug, you'll end up with dv dt, who you don't know. 9/4 pi times dh dt, who you do know. The 4's end up reducing. I just get 9 pi without keeping units the whole time. Kiddos, what are my units going to be for dv over dt? Whose volume?
Feet.
Inches, but inches, you guys got it,
Wait,
per, and what's time?
do it wrong.
No, it's right. It's just really good decrease.
No, because we didn't convert inches to, we forgot to change the 4 to.
We would check in the back of the book. Way to beat me to it. We would check in the back of the book and he would be wrong, but he was so easy. What's the struggle? He was this, and what were we using for R? Okay, so hold on. If R is 3/2 feet, how many inches would he be?
Oh, wait, sorry.
36.
Oh, wait a minute. Look at all my answers. Do I want inches or do I want feet? Oh, well, stink. The 3/2 feet was totally fine. What don't I want?
The rate of change.
Oh, I don't want it to be 4 inches. So hold on. We better just take a second and say, well, that was really easy, but I don't want 4. He doesn't help. I don't want inches. I want feet. So we wouldn't have to worry about it?
I think it's just tense.
How do I change 4 inches per minute to be feet per minute?
Build a bridge.
Build a bridge.
It's 1/3.
How many inches in 1 foot?
12.
Got it. And then, haha, I'll get what I want. Then I'll get what I want. So then 4 over 12 is the same thing as 1 over 3 feet per minute. Now everything is going to match. Let's throw in a 1/3. My 4 is still chilling. This time the 3 actually reduces with the 9. The correct answer would be 3 pi over 4 feet per. Is that an answer?
Yeah, but technically it's negative. Okay.
But why is it negative? What was the one thing we missed?
Going downwards.
The water level height was 4, but it was draining at a rate of 4. Draining means decreasing. So we'd have a negative, we'd have a negative, we'd have a negative, we'd have a negative. It's decreasing. But if you guys understand what the negatives mean, decreasing, you should be like, oh yeah, duh, of course it's negative. The final answer is D. Okay. with that, we've done 44, we've done 45. They might have been a bit tricky. We reviewed our related rates. Can I have you guys come on back? Number 17 was a sand problem, right? What problem is the trough problem?
20.
20. Let's do one more. Number 20. But I need you guys, someone to have either the problem they wrote down last night or either the problem they wrote down last night or their book in front of them to help us out, okay? I'm going to go ahead and make my nifty-dippy chart just because you know me. Do you guys really think I need the chart to keep things organized? No. But, well, I'm not too good for that. But, why do you think I'm trying to make this chart over and over again? To help you make sure you know step by step what you're supposed to be doing. Okay? Alright, who has number 20 in front of them and can read it for us? You have the book? Alright, Ryan, go for it.
A trough is 12 feet long and 3 feet across the top. Its ends are isosceles triangles with altitudes of 3 feet.
Ish. 12 feet, right? And then 3 feet across. And then these are isosceles, which means these are congruent. And there was one of the three. What's the three?
It was 3 feet tall.
3 feet tall. What's inside the trough, Ryan?
Water.
Okay.
Water is being pumped into the trough at 2 cubic feet per minute. How fast is the water level rising when the depth h is 1 foot?
Okay. That's our scenario. Water being pumped in. Kiddos, if they tell us water is being pumped in, what can I say for my given? Water is being pumped in at a rate of, what was it again?
2 cubic feet per minute.
Okay. 2 cubic feet. Wait, that should help us. dVdt. Does that make sense? Water being pumped in, so there's some sort of hose line the water is going in. So I know dVdt is a positive 2 because everything is increasing. It was cubic feet per minute. Cool. What do they ask us? There must be some sort of question to find. Read me the wording now. Read me the wording now.
Water is being pumped into the trough at 2 cubic feet per minute. How fast is the water level rising when the depth h is 1 foot?
Ooh, water level. Water level. 3. No. Water level is for just the water, right? Bridget, what did we name it last time? Remember? Which one? Yeah, height. Good. So, height, water level. If the height, the water level is changing, that'd be fine dH dt, right? Such that, and what they say when height is 1?
Yeah.
1 foot.
1 foot. Oh, whew. No crazy dimensional analysis building bridges this time, right? Well, wait a minute. What on earth is my formula, guys?
You need to find the area of a triangle times the depth.
Volume. Yeah. Now, the nice thing is, remember, they assume that we don't know geometry so good. So let me give you a formula. Sound good?
Yes.
V is equal to, let me label a few things. Let's call this one, which is how far across, we'll call him X. We have height, and then this one will be depth. Does that work?
Mhm.
So we can say it's going to be 1/2 base, which is going to be X, times height, times depth. Now, they'll probably put something better and like put different variables, yada, yada, yada. But anyway, I have the right idea. Question. Oh, there's so many variables. That's disgusting. Does anything stay the same as the water rises? Violet. Yeah. D stays the same. Do you see it? As the water goes up and down, isn't it still filling the trough all the way across? So can't I change D to be a constant and say, oh, sweet. All right, hold on. V is equal. D is just 12. Always, 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 right? D is just 12. 12 over 2 is 6. So I have 6, X, and then H. Do you see why I chose this problem? I see the V. I see the H. Who doesn't belong? Again, I have somebody extra. Well, this time, does x change?
Yes.
Stink. Okay, hold on. X changes, which means I can't just plug in a number because he's not a constant. But what's true?
This is
Ready? In geometry, I'm going to erase this in a second, but in geometry, when you have a big triangle with certain dimensions like 3 and 3, and then you have a similar triangle with the exact same proportion of sides, what can you say about its distance across and its height? Sides are proportional. So I can say 3 to 3 must be h to x, or another way of saying it, I can say the height of the big one over the height of the little one equals the length of the big one over the length of the little one. Similar triangles. Corresponding sides of similar triangles are proportional. It's like CBCDC, but harder. And what does that mean? 3x equals 3h, and 3x equals 3h, and some of you might have seen it from the picture. Even though x and h are going to be smaller, what's still true about both of those dimensions? They're the same. Oh, sneaky little, they made us go back to geometry and think about similar shapes. This is the trickiest homework we'll get. You had to figure out, well, if they tell me it's 3 by 3, the little one is going to be x by h, they're the same thing. So then how does that help me? What can I do with x then? Say whatever, he's h. So I can say v is equal to 6 times h times h, 6h squared. Oh, how is my life so much better now? Now we have a dh dt and a dv dt once we take derivatives, and we don't have to worry about that nasty x being in our way. But what thing from geometry did we have to think about? Similar triangles having proportional sides. And then when we solve, we get dv dt equals 12h dh dt. And all we gotta do, kiddos, is what? Plug and chug that stuff. I know that volume is equal to 2. I know that h is equal to 1. Everything lines up in the sense of feet with feet. I have dh dt over here. So dh dt is going to end up equaling. Don't mess up on your algebra. You've gotten so far. Divide by 12. 2 over 12 is 1 over 6. What do you think the units are if it's heights measurement over times measurement? Feet per time. Oh my goodness, I think we've done like 4 homework problems. Anyway, I'm stopping. Go ahead and get out your colored pen. Get out your spiral. I'm going to go through the answers, the final answers to the evens. If you don't have them done, that's okay. Write them down maybe at the very top of your homework, and you can check the answers as you go. Sound good? Yeah.
That's the base of the water.
Yeah. Like it's weird because it's kind of the triangle's upside down, but it's the base of the water. All right, the even, section 2-7. Someone who has the assignment. Oops, that's recording. Keep recording, please. There we go. And this way, guys, also, what am I taping right now? The answer key with the steps and not just the answers. So if you go to the video, couldn't you pause it and couldn't you look at the whole solution for the evens like CalcChat?
Yeah.
All right, what's our first even? 6. So if you wanted to, you could access the video online and pause it here and then check all the steps. Or just take pictures, you lazy bums. All right, final answer for A. If you want to take pictures, you may as well. Final answer for A, 24 over 25 inches per second. B, 0 inches per second. C, negative 24 over 25 inches per second. A couple more seconds. Where am I going next? 14. If you want to take pictures, you may. If you want to get out your phone, it's okay. 14. A, 2 over 9 pi centimeters per minute, which I guess you could go to decimals, they just left it with pi. 2 over 9 pi centimeters per minute. B, 1 over 18 pi centimeters per minute. As we're finishing that one, I'm going where? Let's double check we got it right, but hopefully we did, huh? Number 20. Whoo! There he is.
Yeah.
1/6 feet per minute. 1/6 feet per minute. Now guys, their work's not wrong, but our work makes it nice, neat, organized, and you don't get lost.
Yeah.
Letter B, there is a letter B. There is a letter B. 3/4 feet cubed per minute. They give you a different clue, so you have to kind of rearrange things up here. They called it base instead of x. I called this x. They called it b, but either way, it ends up working. But b, 3/4 feet cubed per minute. Number next one. See the baseball one? Who's his picture? I think it's the one below, right?
Yeah, it's the one below.
28. Final answer. Oh, no. Never do 2 decimal places. Don't do this. 3 decimal places. Please, please, please. Never 2. But they have as the final answer 15.35. Make sure it's 3 decimal places, feet per second. If I had a calculator close, I would actually solve it. 15.35 feet per second. Only one. Oh, nope, there's a part B. B is 10/3 feet per second. Hey guys, did we have a baseball problem that we worked together in our groups on? Is that saved online in the notes for us to kind of copy? Just think about it.
B is a different problem.
Oh, really? Oh, that's the shadow. Thanks, Ryan.
Yeah.
Never mind, guys, just 15.35. But we did the shadow one too, didn't we?
Yeah.
Is that number 29?
Yeah.
Okay. Number 29, my picture people, it's all on there. 29A, 25/3 feet per second. If you guys notice, I said the shadow one was hard. Why? We have similar triangles yet again. Similar triangles yet again. If you notice, they do a proportion also. They do a proportion with those similar triangles, just like we did a second ago. 25/3 feet per second. Letter B, 10/3 feet per second. Number next one.
44.
44. You guys got it? 44, final one. Hey, he's the one we just did. Was the answer B? I think so. Why did I give you so many odds? Because if you think about it, there weren't that many evens. I wanted you to be able to calc chat it, okay? Now, remember, we have number 20A all done. B, just the information changes a little bit. We have number 45 and 44 done as well. And number 17 is on the board if you want a picture for, I don't think I finished it, but I set it up pretty good. Kiddos, I know we have these AP ones. We're not going to stress too much about these until after the test. Right now we just kind of need to prepare for the test. But if you notice, look at this problem. Hey, it's a cone. Funny. Hey, it's a cone with similar triangles. Oh my goodness, 10 over 10. So R and H must be, they give me the volume formula. It's a pretty typical problem. And it looks a lot like our homework problems. Anyway, so the point of what we're doing is applicable. Homework number 15, no, not number 16. I had that number wrong. Isn't it 16? 16. Section 2.7, technically due today, but in a way you can think due tomorrow. That's an old practice test, not that one. We have, instead of a practice test, we have the chapter test review, right? If you guys haven't written that review down yet, let me go ahead and get it on the screen. You might want to write it in your spiral. I'm going to go ahead and just let the end of class be. Is he on here? Oh, he's not on there. Let me pull him up. Goes all times. Oh, I finished talking. We have a little bit less than 5 minutes. So kiddos, if you are on a certain place in homework, as soon as I get this test review up, I can come answer any questions. If you want to ask your group anything, feel free, go ahead. Tomorrow in period 6, and for the little bit that we have in period 1, we're not talking about 2.7 homework. So if you have questions, come in at lunch, come in after school today on 2.7. Tomorrow we're just doing a quick like, hey, chapter 2B, where have we been? And what's going to be looking or waiting for us on the test on Friday. Those of you guys that are stressing about the related rates problems, if there was a problem with nasty decimals, I would let you use your calculators. But some of these, like the 1/9 pi sort of thing, that didn't need a calculator. The square root of 3/4 didn't need a calculator, so just be aware you might not need a calculator. All right, the test review, if you need it to write down. Oh my goodness, computer, stop freezing.
Maybe we should warm it up.
I thought I did. He's been working for a while. There he is. And remember, only the last few are related to race ones. The rest of them are like, hey, it's missing. You take easy extra stuff. Hey, they were strict. You take a derivative stuff. Does anybody have any questions on the their stuff on it? It wasn't really okay.
How much time do we have?
Give a couple minutes. So guys, I know it wasn't just a random work day, but I'm hoping it helped. You got almost four full homework problems worked on. For right now today. Keep it after. If you come after or during lunch or after school and we're working on stuff, that can kind of figure it out. You just study with a friend, that can count as tutoring hours. If you grab a BC or you say help with this stuff, because they need to know it too. Or remember it too. That counts. That's what Andrea and Joyce did this morning. Today's the 19th, right?
Is it really?
Yeah.
Oh my gosh.
Isn't that crazy? October's just
Yeah, where did October go?
Guys, it's almost time to turn on the opposite side.
Maya's birthday tomorrow?
One country's on.
You guys, partying up.
This is really comfortable. I don't know why.
It's allowed to be comfortable. Probably. I don't remember who.
Oh, maybe it's actually so much better.
Homework number 16. Alright, so I'm just putting keep working on homework 16 and the test review. Keep working on homework 16 and the test review. Test is Friday. I'll be here after school. Remember, tomorrow's a short class. Don't depend on it. Bridget, you doing alright, kid? I haven't seen you in a lot. I was just wondering.